All right, let's jump right in. Today we're going to talk about something that connects pretty much everything on our planet, food. We're going to unravel these incredible, sometimes hidden relationships that are all driven by that one simple need, to eat. So let me ask you a question to get us started. Does any living thing out there truly live all by itself? The short answer, nope, not a chance. But it's the how and the why of those connections that's just so fascinating. Seriously, from the tiniest microbe to the biggest whale, everything is linked. And you know what that hidden link is? It all boils down to one thing, one single driver connecting every living creature: the search for energy. Think of it like the universal currency of life. Okay, so if we want to understand these connections, we've got to follow the money, right? Or in this case, follow the energy. And for pretty much all life here on Earth, that journey starts in the exact same place, the sun. Right at the bottom, the foundation of everything, you've got the producers. These guys are the ultimate self-starters. We're talking about plants, algae, organisms that can do something amazing. They take sunlight and, through photosynthesis, turn it into usable energy. They literally make their own food. They are the absolute foundation of the whole system. And then you've got the consumers. Now, these guys can't make their own food like producers can. So what do? They've got to get their energy by eating other living things. Simple as that. Whether it's munching on a plant or another animal, that's how they fuel up. So this whole who eats who thing, it creates a direct path for that energy to travel. And that path is what we call a food chain. It's really the most basic way to picture how energy moves through an ecosystem. Let's look at a super classic example. You've probably seen this one before. First, you have the grass. That's our producer. Along comes a rabbit, our primary consumer, and eats the grass. Boom, energy transferred. Then a snake eats the rabbit, energy transferred again. And finally, an eagle swoops down and gets the snake. See that? It's a straight line, a clear path of energy moving right up to the top. Okay, so we've got the basic path down. Now let's zoom in on the most dramatic type of interaction you see on that path. We're talking about predation, and you can think of it in simple terms. It's a plus/minus relationship. One side gets a huge plus. They get energy. The other side gets a massive minus. Because, well, they lose everything. The roles here are crystal clear, right? You've got the predator, that's the hunter. It gets the food, the energy it needs to live. And then you have the prey, the one being hunted. Its body, its energy is what keeps the predator going. And this dynamic is everywhere in nature. I mean, think of that classic image of a lion chasing a gazelle, or a polar bear hunting a seal on the ice. But it's not just big animals. What about a Venus flytrap? That's the Diania plant, snapping shut on an insect. It's the exact same relationship. One wins, one loses. But, it's not always so violent or so cut and dried. Nature is way more complex than that. Lots of species have actually evolved to live together in really close long-term relationships. And this is what we call symbiosis. Let's start with the best-case scenario, mutualism. This is the ultimate win-win. It's a plus/plus relationship. Both sides benefit, and this cooperation helps them both do more than just survive. It helps them thrive. And these partnerships can be absolutely essential. Just think about bees and flowers. The bee gets food, that sugary nectar. And what does the flower get? It gets pollinated, so it can make more flowers. It's a perfect trade. Or look at coral reefs. All those incredible vibrant colors, that's thanks to tiny algae living right inside the coral. The algae gets a safe place to live, and the coral gets food from the algae's photosynthesis. It's a beautiful system where both sides get something they desperately need. Okay, next up is a kind of weird one, commensalism. This is a plus-zero relationship. So one organism gets a real benefit, maybe a free ride or some leftover scraps, and the other one, it gets nothing. It's totally unaffected. It's like they don't even know the other one is there. The classic example here is the remora fish. You've seen them, right? They stick themselves onto sharks. They get free transportation and get to eat the scraps from the shark's meal. And the shark, honestly, it couldn't care less. It's not harmed, not helped. Same thing with barnacles on a whale. The barnacles get a nice moving house with a constant flow of food, and the whale, well, it's just a whale. It doesn't even notice. All right, our last type of symbiosis is parasitism. And we're back to a plus-minus situation. So just like predation, it's a win-lose game. But here's the difference. Instead of a quick hunt, this is usually a much slower, much more intimate kind of conflict. With parasitism, the parasite wins by hurting its host. Think about ticks. They latch on and feed on blood, and can even pass on diseases. Or even worse, tapeworms that live inside an animal's gut, literally stealing the nutrients from the food the host just ate. It's a pretty raw deal for the host. Okay, so we've looked at all these individual one-on-one interactions, the food chain, predation, all the different partnerships. Now it's time to zoom out. How do all these little links connect to create the big picture of an entire ecosystem? Because in the real world, it's almost never a simple, straight line. It's not a chain, it's a food web. And that's a much better word for it, because it's a tangled, complex, well, web, and a much more accurate picture of how energy really moves around. I mean, just look at how this works. That eagle from our food chain, it doesn't just eat snakes. No way. It's also going after rabbits, maybe some fish. And that rabbit, it's not just food for snakes. A fox could come along and eat it too. This is what a real ecosystem looks like. It's this incredible web with tons of different connections. But now we get to what is, for me, the most mind-blowing part of this whole thing. The way energy moves through this web, it is shockingly inefficient. Get this, when energy moves from one level to the next, only about 10% of it actually makes the trip. That's right, a full 90% of the energy is lost at every single step, mostly just as body heat. And this huge energy loss is exactly why food webs aren't super tall. You just run out of energy. There's not enough left at the top to support, a predator that eats the eagle that ate the snake. This one simple fact shapes the entire structure of life as we know it. So all this inefficiency means the whole web is way more delicate than you might think. If you pull out just one species, just one little string, the effects can ripple outwards and mess up the whole thing. And that leaves us with one last really important question to think about.